So now we are going to see about polar plot. Very good afternoon, dear student. So from the polar plot, we are going to find out phase and gain margin. So this is given problem. The open loop transfer functions of unity feedback system is given by g of s equal to 1 divided by s into 1 plus s into 1 plus 2s. Already we know that g of s is nothing but open loop transfer functions. So g of s equal to 1 divided by s into 1 plus s into 1 plus 2s. This is given transfer function, open loop transfer functions. Now sketch the polar plot and determine the gain margin and phase margins. Okay. Sketch the polar plot. After sketch the polar plot, then we can able to find or determine the gain margin and phase margin. So from the given equations, open loop transfer functions g of s equal to, you know that 1 divided by s into 1 plus s into 1 plus 2s. So this is normal transfer function of sinusoidal. Normal sinusoidal transfer functions. Now we are going to, sorry, this normal frequency transfer functions. Now we are going to write into the sinusoidal transfer functions. Already we know that we have to substitute, submit s equal to j omega, means the j omega s is replaced by the j omega. S is replaced by the j omega. The j omega for sinusoidal transfer functions. So g of j omega equal to 1 divided by j omega into 1 plus j omega into 1 plus 2 j omega. So instead of yes, we put j omega because of we are going to write sinusoidal transformation. So j of j omega equal to 1 divided by j omega into 1 plus j omega into 1 plus 2 j omega. We have three terms. In the numerator, we don't have any term. The denominator, we have the three terms. What are the terms? The first term is j omega, second term is the 1 plus j omega, third term is 1 plus 2 j omega. We have three terms in given transfer function. Now, from the given term, we are going to find out the corner frequency. To find corner frequency, what is the formula for corner frequency? Omega c equal to real value divided by the imaginary value for each term. We take each term. This each terms we have to see whether the term having both real and imaginary. If it is having both real and imaginary, we can easily find out. So the corner frequency omega c equal to real value divided by imaginary for each term. The first term we know that j omega. First term you know that j omega. J omega is imaginary value. Then first term, in first term there is no real value. Okay, so that is called 0. 0 divided by 1. Okay, 0 divided by 1. Imaginary value is j omega is there, so you put 1. Real value 0, so 0 divided by 1, that is called 0. So there is no corner frequency for first term, j omega term. The second term we are going to take 1 plus j omega. So you know that 1 plus j omega, the 1 is real term, j omega is the imaginary term. So 1 by 1. So 1 by 1 is that. The third term is nothing but real value 1 and imaginary value 2. Real value 1, imaginary value 2. Now 1 by 2. So now we are finding that corner frequency. We take omega c1 equal to 1 divided by 2. Why we take the third term first means it having lower minimum frequency compared with the second term. It has less frequency compared with previous term. I mean the second term. The third term having 1 divided by 2 is nothing but 0.5 radians second. So we take omega c1. So we take omega c1. Omega c1. Then next second term corner frequency 1 divided by 1, that is equal to 1. So 1 radian per second. So according to this, we have to choose omega C1 and omega C2. Okay. Now we have two frequency, corner frequency. The first frequency is omega C1 is nothing but 0.5 radian per second. The second frequency omega C2 equal to 1 radian per second. We have two corner frequency. Now we are going to find out the magnitude and phase angle. First we move to find the magnitude value. So we know that the formula magnitude within that one table we give that a plus ib equal to root of a square plus b square. We want to find the magnitude for these complex functions a plus ib, that is equal to root of a square plus b square. So magnitude of g of j omega is nothing but from the equations 1 divided by from the equation 1 divided by root of what? First term, what is the first term? J omega. J omega is there. Now there is the no real part, only imaginary part. So real part is 0 plus omega. The imaginary part we have j omega is there. So 0 plus omega square. A 0, b is nothing but omega. Here omega square. 0 plus omega square. Then the second term you know that 1 plus j omega. So a equal to 1, b equal to omega. So 1 plus 1 means 1 square nothing but 1. 1 plus omega square. Then from the third, here the third term. These terms. From third term 1 plus 2 j omega. A equal to 1, b equal to 2 omega. A equal to 1, b equal to 2 omega. So 1 square is nothing but 1 plus 2 square into omega square. 2 square into omega square. Further, we have to simplify. Equal to 1 magnitude equal to 1 divided by root of 0 plus omega square is nothing but omega square into 1 plus omega square into 1 plus 2 square is nothing but 4 omega square you put. Then again you have to simplify. The magnitude equal to 1 divided by, we have to take omega square, take out from that root omega square tends to omega. Okay, 1 divided by omega root of 1 plus omega square into 1 plus 4 omega square. Now we are going to multiply this two term into the roots. Okay, 1 divided by omega root of 1 into 1 1 plus 1 into 4 omega square 4 omega square, then plus omega square into 1 omega square plus 4 omega square into 4 omega square 4 omega power 4. So we have 1 in the root 1 plus 4 omega square plus omega square is nothing but 5 omega square plus 4 omega power 4. So finally we get the equations, magnitude equations. Magnitude of g of j omega equal to 1 divided by omega root of 1 plus 5 omega square plus 4 omega power 4. So we want to form the magnitude equations. We know that in the functions, in the transfer, in the terms, it has both real and imaginary part. Means the magnitude is nothing but a plus ib equal to root of a square plus b square. We are going to find for each and every terms which we are having from the transfer functions. From the transfer functions, each terms having the both real and imaginary, then we have to write like this. So now we form the magnitude equations. Next we move to the phase angle equations. How we are going to form. So we know that the magnitude equation is nothing but 1 divided by omega root of 1 plus 5 omega square plus 4 omega power 4. Next to find phase value. To find phase value. Now phase value is nothing but real plus imaginary part a plus ib equal to tan inverse of imaginary divided by real. Imaginary divided by real. So imaginary here is nothing but B, real is nothing but A. Now, angle of now we are going to take angle of G of J omega. Angle of G of J omega is nothing but we have to write that equations. Angle of G of J omega equal to 1 divided by angle of tan inverse. Angle of tan inverse. You are going to write for each terms. We have three terms. So tan inverse B by J. Tan inverse from the equations. Tan inverse. What is the B? B is nothing but omega because of the seventh only imaginary part. Omega divided by A is nothing but 0. The tan inverse of omega divided by 0 is nothing but omega divided by 0. Anything divided by 0 is nothing but infinity. Tan inverse of infinity is nothing but 90. You know that. So here, for we are going to take in angle, we know that in multiplication factor is convert into the addition. The division factors is converted into the subtractions. So we get that multiplication factor. So we are going to add here. Each term, the three terms are in multiplications. So you put in the additions. So the first term tan inverse of omega divided by 0. So it's nothing but tan inverse of 0. It's nothing but tan inverse of infinitive. It's nothing but 90 degree. Plus tan inverse of it is for second term. Tan inverse of b by a. B we know that 1 plus j omega. So 1 plus b is nothing but omega divided by a is nothing but 1. But tan inverse of 1. I means tan inverse of omega. Plus for the third term, tan inverse of b term is nothing but, I mean the third term is nothing but 1 plus 2j omega. 1 plus 2j omega. 2j omega means 2 omega is nothing but b, 1 is nothing but a. Tan inverse of b by a means tan inverse of 2 omega divided by 1. So finally we get that is equal to 1 divided by 90 plus tan inverse of omega plus tan inverse of 2 omega. So 1 divided by we have that 90 plus tan inverse, these function in the denominator. 90 plus tan inverse of omega plus tan inverse of 2 omega is in the denominator. If you want to move from denominator to numerator, there will be some sign changes. Already we said that divisions is moved to the subtractions. So negative signs. So 19 minus 90, so the denominator is moved to the numerator, minus 90 minus tan inverse of omega minus tan inverse of 2 omega. This is this equation for phase angle. So now we have the two equations. The first equation for magnitude, first equation of magnitude, g of j omega is nothing but 1 divided by omega root 1 plus 5 omega square plus 4 omega power 4. This is for magnitude. To find the magnitude values with respect to the different frequencies. The next it is for frequency. It is for phase angle. Okay, angle of g of j omega is nothing but minus 90 minus tan inverse of omega minus tan inverse of 2 omega. This is for to find the phase angle with respect to the different frequency. So now move to choose the frequency, different frequency. Choose the different frequency. What are the frequency we taken? 0.35, 0.4, 0.45, 0.5, 0.6, 0.7 and 1. So here I mentioned in a red mark 0.5 and 0.1. It is in corner frequency we found from the given transfer functions. If you are choosing the different number of frequencies means definitely a choosing frequency must consist of which frequency we get from the transfer functions. So what are the frequency we get from the transfer functions? 0.5 and 1 radian seconds. 0.5 radian second and 1 radian seconds we get from that transfer functions. The remaining we have to choose based upon your requirement. Okay, so here we start from the 0.35. If you want to 0.2, take 0.2, 0.4, 0.6, 0.6, I mean 0.5, 0.6, 0.8, 1, 1.2, etc. etc. But the choosing frequency must consist or contain the frequency which we get from the transfer functions. Okay, these are the frequency we found. From this frequency, we are going to calculate the magnitude and phase angle with respect to the different frequency what we choose. What is our first frequency? Our first frequency omega equal to 0.35 radian per second. Our first frequency omega equal to 0.35 radian per second. So we put that value. So at omega equal to 0.35 radian per second. Now first you find out the magnitude. Already we know that the formula for magnitude, equation for magnitude we get 1 divided by omega root of 1 plus 5 omega square plus 4 omega power 4. So instead of omega we put 0.35. Now magnitude equal to 1 divided by omega replaced by 0.35 root of 1 plus 5 into 0.35 whole square, sorry, square plus 4 into 0.35 power 4. Now to simplify this one, we get 2.2. Magnitude, we get the magnitude 2.2 at the frequency 0.35. The same frequency, we are going to find out the phase angle. Same frequency, we are going to find out the phase angle. Phase angle formula also we got, that is equal to, from the transfer functions, we know that minus 90 minus tan inverse of omega minus tan inverse of 2 omega. So minus 90 minus tan inverse of, instead of omega we put 0.35 minus tan inverse of 2 into 0.35. Now we get minus 144. So magnitude 2.2, phase angle 1 minus 144. In which frequency? In which frequency we apply 0.35. At the frequency 0.35, we get the magnitude 2.2, phase angle minus 144. Next, we put another next corner frequency, choosing frequency 0.4 radian per second. Then you have to substitute this value, omega values, in this both magnitude and phase angle. Directly I substitute the values. Then we got 1.81 magnitude for 0.4 radian per second. The same 0.4 radian per second we get phase angle minus 150. Then 0.45. We substitute the value 0.45, omega value 0.45 for both phase magnitude and phase angle. We get 1.5 magnitude, phase angle minus 156. Then 0.5 radian per second we apply for omega. We get magnitude 1.3, phase angle minus 160. Then 0.6 radian per second we apply. We get the magnitude 0.9, phase angle minus 171. Then next we put 0.7 radian per second. We get the magnitude 0.7, phase angle minus 170. At omega equal to 1 radian per second, we got magnitude 0.3, phase angle minus 198. Minus 198. So here you know that. So for all frequencies, all choosing frequency, we get both magnitude and phase angle. Both magnitude and phase angle. Now we are going to draw the plot. Now we are going to draw the polar plot. Now this is polar plot. I draw corner frequency. What are the frequency we choose? 0.35, 0.4, 0.45, 0.5, 0.6, 0.7, 1. Or the particular corner frequency, we get the magnitude 2.2, the phase angle minus 144. For corner frequency 4, we get magnitude and phase angle. For 4.5, for 5, for 6, for 7, for 1 we get magnitude and phase angle. Now we are going to draw the polar plot. It's not for the corner frequency. We draw the polar plot magnitude versus phase angle. We draw the polar plot magnitude versus phase angle. So now you have to see that this is like polar plot. The circle is there. Blue color circle is given here using the different color pen. Here with the x-axis we take from 0 degree to 180 degree. That is called x-axis. Then y-axis we take 90 degree. Okay, 90 degree bottom. It's like minus, sorry, 270 degree. So here is given value degree. There's a 0, 15 degree, 30 degree. In anti-clockwise directions, we put in the positive degree. In the clockwise directions, I mark it like this: minus 15 degree, minus 30 degree. It is in clockwise directions. Okay. Now on the same polar sheets, we have both positive and negative angle. So here now we are going to put. So we choose here the circle is there. The first blue color circles I take 0.5, second circle 1, third circle 1.5, fourth circle 2, fifth circle 2.5, sixth circle 3, then seventh circle 3.5. So the depend upon our requirements. Okay, we having the magnitude zero point 0.3, less magnitude zero point 0.3, highest magnitude 2.2. We get the magnitude point less 0.23, highest 2.2. Okay. Now, so far only you take point. Otherwise, you take for the first circle you take zero point 0.3, then zero point 0.9, then 3.3. You have to the scale will be in regular. I mean uniformly. You have to choose. If you choose the zero point 0.3 first means the second circle is 0.9, then point it's a 1.2, then 1.5, then 1.8 like this. You have to. But here we take the first blue circle is 0.5, the second blue circle 1, 1.5. Here the circle we give the value, we increasing the value 0.5, 0.5, 0.5 in error. So the first circle 0.5 na, second 1. So each circles increased by the 0.5. So now the magnitude we here given for this exercise. Now we are going to draw the polar plot magnitude versus phase angle. For here, for 2.2, for 2.2, we know that here 2, the whole circle, we mark the 2 is there now. The whole blue circle, it is called 2. It is called 2. The 2.2 means the whole circle which I marked in the 2.5, the blue color circle, the whole blue color circle is called 2.5. Okay, the same like this. 3 I marked 3 here. The whole circle is called 3. So the 2 between the 2.5 we have magnitude 2.2. Between 2 2.5 na, between one light what gray color circle is there, that is called 2.25. That is called 2.25. So we are going to 2.2. 2.2, 2.25 is more or less same. So we take that middle between the 2 to 2.5, the middle gray circle we have. We take then the particular 1 point minus 144 phase angle you have to choose. 144 phase angle. This is 135 is there. After 135, 140, 145, 150. So each scale is in degree, uh, 55, 135 degree. Then the middle is 2 is there now. 135, 140, 145, 150. Okay. So here. So now with respect to 2.2 minus 144, we getting here. This is called A. The next one is 1.81. 1.81 is here. Then minus 150 degree. Just you have to mark that 150 degree is there. Exact. The second value. Then third is 1.5. Magnitude says the minus 156. Minus 150, 155, 156 na the little I mean little greater values with respect to the 150. So 156. Then 1.3 with respect to 1.3 magnitude and minus 161 phase angle. You have to combine this 1.3. Just you have to see that minus 161. At the time when you are writing the exam, use the scale for finding the angle. Okay, the point between the angle and magnitude. Find the point between the angle and the phase angle and magnitude. For 0.9, it has minus 1.71. For 0.7, minus 179 is nearest to 180 degree, minus 180 degree. Point 3, we get minus 198. Minus 198. Okay. So now we are going to connect dots, all the dots. Then you complete towards to zero in middle. Start to draw and connect all the dots. Then it's draw up to the middle zero mentioned in your graph sheet. Now the point 5 is there, one is there. Point 5 is there, one is there. Here the one is nothing but here the yellow color I given the one circle. One circle I draw for one circle by using that yellow color. The circle value of one is nothing but unity circle. Unity circle. The unity circle it's cut the graph. I mean the polar plot in which point here one point is now the corresponding frequency is nothing but minus 169. Minus 169. This is called gain crossover frequency. Here you draw the line at which in one magnitude. The one magnitude we have here. The one magnitude by using I am using by yellow color pencil. I draw that line. The this is the line called unity circles. That unity circles cut the polar plot at a particular point. That from that particular point we have to measure the phase angle. We have to measure the phase angle. That is called we get that phase angle minus 169 degree. Minus 169 degree. So here this is nothing but gain crossover frequency. This is first one. The second one, that minus 180 degrees there. Now second one we need to find out the phase crossover frequency. First we find out the gain crossover frequency. We know that, and which point which the polar plot we draw the polar plot, the plot which cut the unity circle from that point corresponding angle it is called as the gain crossover frequency. Yes, now we get minus 169 degree. It is maybe, it depends on your scale, it is maybe vary minus 170 or minus 168. Whatever maybe, this is a small difference with respect to the which you take the angle on scale. Second, we need to find out the phase crossover frequency. We know that phase crossover frequency means at minus 180 degree line is there in x-axis. At minus 180 degree, it cut the polar plot. We draw the polar plot now. That polar plot, it cut the minus 180 degree, and which point? That from the which point to zero, we have to measure the values. From zero to that point, we know that point 0.7. Magnitude is nothing but 0.7. Okay, this is called magnitude. Here, magnitude means at minus 180 degree, one x-axis is there. We choose the x-axis 0 to minus 180 degree. Now, from that minus 180 degree, it cut the polar plot. Okay, from that at which that point we have to measure from that point to towards zero the values. From that point zero to the cutting point of minus 180 degree, the polar plot cutting point of 180 degree is nothing but 0.7, and the dark maroon color I given 0.7 is mentioned. Okay, so now we know that. Now we complete all the thing. We complete all the thing. Now we move to so now next we move to so here you are going to find out the phase margin and gain margin. So you know that phase margin gamma equal to 180 degree plus pi GC. Pi GC is nothing but gain crossover frequency. Gain crossover frequency. What is the gain crossover frequency? Minus 169. We found from that polar plot. So 180 degree plus, this is not a minus, 180 degree plus pi GC. Pi GC we get minus 169. So now get the phase margin equal to 11. 180 degree minus 160. This again, gain margin kg equal to 1 divided by magnitude of GFJ. What we are getting the magnitude at phase angle 180 degree minus 180 degree cut by the polar plot. From that point we have to measure the magnitude value towards 0. From 0 to that cutting point we get 0.7. So gain margin is nothing but 1 divided by what we get from value at the axis of minus 180 degree, 0.7. So that is equal to 1.42 is the gain margin. 1.42 is the gain. So this is what you are doing using the polar plot. Yes, can you able to see that polar plot? If you want to explain once again, anybody? Student, are you there?
Yes, sir.
Okay. The polar. Can you able to hear me?
Yes, sir.
Okay, the polar plot. You saw the polar plot.
Sir, voice break on, sir.
So now it's okay.
இப்போ ஓகே சார்.
அந்த polar plot பாத்தீங்களா? நான் காட்டினேனே வந்தது அது. Do you see the polar plot?
சார் இப்போ எதுவும்
இந்த plot இப்ப தெரியுது இந்த polar plot. பாத்தீங்களா முன்னாடி?
எஸ் சார் பார்த்தோம் சார்.
முன்னாடி வந்ததா? இதை நான் எக்ஸ்பிளைன் பண்ணது புரிஞ்சிருச்சா? மேக்னிடியூட் ஃபேஸ் ஆங்கிள் வச்சு 2.2க்கு எவ்வளோ ஃபேஸ் ஆங்கிள் அந்த டாட் வச்சுட்டு அதை டாட் பண்ணிக்கணும். அதே மாதிரி 1.8 மேக்னிடியூட் 1.81 மேக்னிடியூடுக்கு -150 டிகிரி ஆங்கிள் இதை மார்க் பண்ணிட்டு தென் எல்லா பாயிண்ட்டும் கனெக்ட் பண்ணிட்டு டுவர்ஸ் ஜீரோவில் கனெக்ட் பண்ணிடணும். தென் இந்த யூனிட்டி சர்க்கிள் ஒன்றுன்னு நம்ம கொடுத்துருப்போம் இல்லையா, 0.5 ஒன்று நம்ம கொடுத்துருக்கோம். whatever maybe start from the 0.5 or start from the 0.3, start from the 0.2, definitely it is cross 1 and above. And the one circle you have to mention using any color pencil. You have to draw the circle, and that circle cut by the magnitude plot, no polar plot, cut by the polar plot. The corresponding frequency is nothing but gain crossover frequency. From our graph we get gain crossover frequency -169. So this is gain crossover frequency. Then phase crossover frequency. How we find the phase crossover frequency? At -180 degree lines is cut the polar plot. The -180 degree line is cut the polar plot. In that point, from that point, we have to measure the magnitude. So from that point towards 0 or 0 towards 2, that point which cut by the -180 degree. So that is called 0.7 we have. So from this only, we have to find the phase margin and gain margin. Okay. Body plot 5 minutes fattalala. What about others? Ganesh?
Sir, வேற
class இருக்கா?
இது சாஃப்ட் ஸ்கில் வேற இருக்கு.
சாஃப்ட் ஸ்கில் இருக்கா? சரிம்மா, கிளாஸ் ஃபைண்ட் அப் பண்ணிடலாம். ரெக்கார்ட்ஸ் எப்போ இது பண்றீங்கப்பா? when you are going to submit record, சீக்கிரம் கொடுத்துக்கிட்டீங்கன்னா இட்ஸ் பெட்டரா இருக்கும்.